Random variables x and y have joint PDF f of x y equals c times x times y squared. For x and y in the unit square, 0 elsewhere. For parts to solve, find the constant c, find p of x greater than y, and p of y less than x squared. Find p of the minimum of x and y at most 1/2. Find p of the maximum at most 3/4. Here is the unit square domain. The diagonal y equals x and the parabola y equals x squared will be the integration boundaries for part B. Watch the dot trace the parabola. The key insight: the joint PDF is separable. With c equals 6, the PDF is 6xy squared, which factors as 2x times 3y squared. The x part and y part are completely separate. Separability means x and y are independent. Double integrals over rectangles factor into products of single integrals. The marginal PDF of x is 2x. The marginal PDF of y is 3y squared. Both integrate to 1, confirming they are valid marginals. Part A. Normalization. Integrate the joint PDF over the unit square and set equal to 1. Factor the double integral. C times the integral of x from 0 to 1 times the integral of y squared from 0 to 1. 1/2 times 1/3 is 1/6. Setting c over 6 equal to 1 gives c equals 6. Part B. First probability p of x greater than y. The region is the triangle below the diagonal in the unit square. Inner integral of 6xy squared from 0 to x gives 2x to the 4th. The outer integral of 2x to the 4th from 0 to 1 gives 2/5. Second probability p of y less than x squared. The region is bounded above by the parabola y equals x squared. Inner integral from 0 to x squared gives 2x to the 7th. Outer integral from 0 to 1 gives 1/4. Here is where most students make an error. For the minimum, do not integrate directly over the L-shaped region. Use the complement. P of minimum at most 1/2 equals 1 minus P of minimum greater than 1/2. That second event means both x and y exceed 1/2. By independence, P of x greater than 1/2 times P of y greater than 1/2. Using the marginals, 3/4 times 7/8 equals 21/32. Complement, 11/32. For part D, P of maximum at most 3/4. Both x and y must be at most 3/4. By independence, P of x at most 3/4 times P of y at most 3/4. 9/16 times 27/64 equals 243 over 1024. Watch both regions. Red, both exceed 1/2, the complement for the minimum. Gold, both at most 3/4, the direct region for the maximum. The complete solution. C equals 6. P of x greater than y equals 2/5. P of y less than x squared equals 1/4. P of minimum at most 1/2 equals 11/32. P of maximum at most 3/4 equals 243 over 1024. Notice the unifying pattern. Independence turned every calculation into a product of marginal integrals. The key was recognizing the PDF was separable from the very start. This problem reveals a general pattern. For any joint PDF c times x to the a times y to the b on the unit square, the normalizing constant is c equals a plus 1 times b plus 1. The marginals are a plus 1 times x to the a and b plus 1 times y to the b. X and y are always independent for every positive a and b. Watch as the exponent b varies. When b is large, the density of y concentrates near 1. When b is small, it spreads out. What happens as b approaches 0?